In this paper, we introduce an interactive system that animates still images with a novel warping method. Our research is motivated by the following observations. In video-based approaches, they need a huge computation of retrieval process. Besides, such sample-based systems are restricted by the domain, thus the animated objects and kind of motions generated by their system are limited. In our system, we propose a fast animating scheme that directly generate results from users' annotations. And, our system can generate various kind of animated objects with flexible animating styles. In deep learning-based approaches, since the motions in the animating results and the animated regions are under the control of the network, unnatural distortions occur, and, some animating regions are frozen instead of animated, or, the motion in a certain region affects to the surrounding regions. Moreover, in these works, the lack of any reliance on training dataset prevents certain methods from animating arbitrary scenes. We tackle these issues by isolating the regions and animate them independently with our animating scheme. Thus, we remove the boundary artifacts and have more predictable results. In the existing commercial applications, a large of user annotations are needed to control the motion in the results to be realistic in plotograph. Or in PyZloop, the resultant boundaries between the animating regions and static regions are usually abstract. This yields boundary artifact in the results. Besides, the curvature of the strokes painted by users is mostly damaged in the animating results. In our method, we just need some strokes from the users. We remove the boundary artifacts. We discard static pixels in animating region. Thus, ghost artifacts do not occur. Especially, the curvature in motions is well preserved. Given a still image, to generate a looping animating video, we propose an animating scheme that consists of 4 main steps: animating region extraction, flow generation, preserve curve warping, and cycle warping. To extract the regions that are to be animated, we let the user brush along the boundary of the such region. Each selected region is then animated independently by the 3 followed steps. Eventually, all the animated regions are composited back together to produce the final animating video. For more detail of each our animating scheme, please see our paper. To verify the effect of the algorithms used in our approach, we here present the ablation studies. This is the ablation of filtering the animating region. We can see that by discarding the static pixels mixed up in the selected region, we can effectively eliminate the ghost artifact. This is the ablation of using overlapping term when converting the user-specified path to control path. We can see, if we do not use the overlapping term, the result fails in obtaining the smoothness of the animation in the cases that the curvature is considerable, as in this example. Here is the ablation of preserve curve warping algorithm. Obviously, the curvature in the resultant motion is damaged without the preserve curve warping manner. And here is the ablation of cycle warping. If without cycle warping manner, pixels abruptly move backward from the terminal point to the starting point in the cycle. This discontinuity appears simultaneously for every pixel in the image, making it a very noticeable artifact. To evaluate our proposed system, we here show the visual comparisons with 6 prior research. Besides, we also compare our results with the existing commercial applications and artists' work. In this results, the system proposed in Holinsky et al. Fails to recognize the animation regions. Therefore some regions are frozen instead of being animated. And, a noticeable discontinuity artifact still occurs at the gap of 2 adjacent loops in their results. In addition, their system sometimes fails to isolate the animation regions and the still regions. Thus, the still regions will be animated by their surrounding motions. In these results, we compare with Endo et al. Their results are unnatural and difficult to control the estimated motion to be realistic. This is the comparison with a video-based approach. To animate the same input image, the compared system need a huge computation to retrieve the matched patch for every regions. Meanwhile, our system is faster to run the looping realistic video. Apart from above, we also conduct the experiments on Chinese painting. We can see, the compared technique cannot animate dynamic effects. But, our system can create realistic animation with various motion styles and different speeds of flow. Here are the comparisons with Bot et al., which use a set of frames to generate an editing result. In contrast, we only use a single still image, but our results are comparable with their editing results. This is the visual comparisons with a stochastic motion textures in animating pictures. Compared to this method, we do not solve the subtle motion of the boat or the tree such in their results. However, they limit their domain to scene. That is, they solely provides the motion of trees, water, boats, clouds. Meanwhile, our results are more appealing with the diversity both motion styles and animating scenes. Here is the visual comparisons with the existing commercial applications. While Plotograph needs a large number of user annotation to control the results to be realistic, our system just needs some adequate strokes from the user and obtain the appealing results. In this comparison with Pixeloop, boundary artifacts occur in their result. Also, the stone move along the direction of the waterfall causes a noticeable ghost artifact. In addition, the curvature in the motion is mostly damaged in Pixeloop's results. Here are the comparisons with artists' works. We can see there are some considerable artifacts in artists' works. Meanwhile, our system can produce the good results. To evaluate our method, we test it on several still images of different animating objects. Our system also suffers some limitations. In the cases that the input image contains obvious shape, our method may not perform well. Besides, in our system, the animations are created based on the user's annotations. Such in this example, let the water splats in any direction by stone is an issue we plan to investigate in our future work.